Okay, so I did the reverse problem. Those I do recommend using the calculator for because I think it does save you something if you're kind of stuck choosing which one's better. Let me try some of these. So I'm going to do the calculator version as well as the original version, right? So at least 100 miles an hour. So I am sketching the normal curve. I've got a 94 in the middle. I'm adding 2. I'm not actually going to make it to 100, but this might be a time to use the calculator when you feel like the table is not going to be super helpful or super precise. So at least 100 is like tiny amount. So just a warning, this work on the calculator won't give you the z-score. You're going to need it. So let me just go ahead and do that. Right? Pretty sure the z-score for 100 is 6/2. It's exactly 3 standard deviations to the right. Now, if I was to use the table, kind of make this all fit together, make sure I understand what's happening, which is what I'm asking for in the work you show me. 0.99987, obviously not what I'm shading right now. That's this side. Right. And so whenever I look these up, I'm saying I'm connecting the z-score with the percentile that I'm looking up. So I'm saying the chance of having a z-score more than 3, or I could also say the chance of having a fastball more than 100 is 1 minus 0.9987, because obviously I didn't shade all my graph. So that's how I do that. So that's the answer. So it's going to be 0.1% are faster than 100. And then the calculator check is going to be, go to distribution. First turn on calculator. Normal CDF, number 2. And the way this works is you tell it when you'd like to start shading. So I would like to start shading at 100. When you'd like to stop shading. This one's tricky. I don't want to stop shading. I want to shade this forever to the right. So I have to type in infinity. I can't do that. So many 9s will do it. All right. And then the mean and the standard deviation of the graph you're working with. So I can put the 94 in here and a 2. But this is why it won't be giving me z-score. And this is why it's kind of a dangerous path to travel, because z-scores are kind of mandatory. So it'll put this in for you. If you don't have the menu, you have to type it in yourself. And it tells you what I just found out. 0.0013. If I do the next one, this is a less than. Less than 90 is also pretty far, but it's only 2 standard deviations away, right? So 94, 96, 92, 90 right here. Less than. So the z-score there is a 2, exactly. All right, so I'm doing 90 minus 94 over 2. Negative 2. 2 standard deviations to the left. And then if I want to do it by hand, I can. I don't know what my deal is. I just like doing this old school. Negative 2, 0.0228. Chance of having a z-score less than negative 2, 0.0228. And then for a moment, I'm sort of like, hey, did I mess up? Did I look in the wrong part of the chart? Right, that can be a thing. Maybe I'll check it. So second var, so you get the distribution. Normal CDF. When would I like to start shading? At negative infinity. When would I like to stop shading? At 90. And then the mean still 94 and 2. So here's the deal, guys. With these, I might use these on a multiple choice question where my work is not as important, right? That totally agrees with me. So we're going to say 2.3% of fastballs are less than 90. The deal is, if you're not sure what you're being asked to do or how to do it, doing this is tricky because you got to figure out your boundaries and you got to get the communication part right. So be very careful. Right, that was a 0.0228. I did not actually put my final answer on here. That's a concern. All right, the z-score here was negative 2.